Hi guys, in previous video we have implemented the iterator object that we're generating. It still generates the numbers from the Fibonacci sequence. Let's do that using the classic approach without any tricky things. To do that, we will define a function called fib. We will pass the max parameter to it. We will define a list numbers. At the beginning it will be an empty list while a is smaller than max. I believe so. A is actually, firstly a is equal to 0 and p is equal to 1, and a is equal to b and p is equal to a plus b, and numbers append a. Actually this comes later, this is for the next value. Okay, and at the end we are returning the list. And let's call this function fib10 and let's print the result. So if we have no any mistakes, it prints the list of first up to the 10 because the next one is greater than 10. The drawback of this approach is that we are storing all these numbers into the memory as an array. Even if we are not going to use this number for a long time, for seconds for example, that is also a long time, these numbers will remain in memory. Let's redefine this function and create our first Python generator function to solve exactly the same problem, of course. Again, we are passing the max parameter. The initial values are 0 and 1. Let's do it nicely. Okay, the condition. Okay, and we are using a new keyword which will be explained shortly. So, believe or not, this new function does the exact same thing but doesn't use additional memory. It always uses the same amount of memory regardless the value of the max variable. So let's do the same thing. Let's print the fib10. Now probably you expect to see the Fibonacci numbers, but we will see the address of the object in memory, which is fib, which is currently a generator object. So that's why we don't see numbers anymore, because this returns an object and we see the pointer to this object, the space in memory, the address of space in memory where it lives. It doesn't create an array, it creates an object that always has the same size regardless of this number. So what can we do is use a for loop. Let's assign this to generator variable. Use a for loop to print the numbers. This way we will see Fibonacci numbers again. And if we trace the program, we will see that this object is now created, and this calls the fib function, which is actually generator function, and that returns a value of a to the piece of code which called this function. In our case, that's the for loop. For loop gets the number, one number, prints that number. So this function can return the sequence of Fibonacci one by one and gives back control to the to this function, which calculates the new value of a, yields that a, and passes control back to the for loop. So this way we are not wasting our memory, and actually this can be used for pipelining, for organizing, multiprocessing, and so on, and this can be used to do many crazy stuff. This is really a good thing. This helps to save memory. This is very logical. This is very elegant construct of programming. So this is the generator object, and we assigned that the address of that object to our gen variable. Let's see another. Let's illustrate this property in another way. Let's call next function and pass the very same object to that function 4 times, for example. Of course, we can do more, and you can see that every time it returns a new value, and now we need to print to see something. Print. Print, print, and print. Now we will see that each time it will print the next number from the Fibonacci sequence. So this means that this object save the state for the next execution of this very same function. This is not like an ordinary function which removes all the local all the variables defined inside the function. This one stores the minimal amount of needed data to calculate the next value until a is while a is less than max in this case. So this is a generator function in Python. Actually, this is an ordinary function until yield keyword is not defined. Yield keyword makes it a generator function. Probably you are aware of list comprehensions, and you know that this code will print the squares of first 10 non-negative numbers, because this construction returns a list of that numbers. Here range of 10. Sorry, here we see a array of numbers, a list of numbers, because this construction generates a list. But if we change the square brackets to parentheses, we will see that this will print an address to object, because this generates a generator. This creates a generator which can be used for in gen to print all the squares. So this is because we didn't assign this to Jen, sorry. And again, we don't consume extra memory. Every number is calculated exactly when it needs to be printed, or probably you are planning to do something else with that. So this is another way to create a generator in Python. This is not advanced usage of Python generators. You can get a crazy 170 page very cool presentation about all the stuff which can be done with Python generators. I really suggest to get that PDF. I will try to find it and put it into the description. So guys, I insist to read that talk, to practice. If you have any questions, feel free to ask in comments. Subscribe to my channel for new videos, and thumbs up. See you soon.